Back to the Unit 2 practice exam. This is page 3. Again, my spacing's a little off, so sorry. D is at the bottom of page 2. We want the probability that more than 6 people in the sample own a table. And let me back up just a second here. X equals 5 is just that value, 5. Here, B, when it says between 3 and 12, we are adding the probabilities for everything between 3 and 12, but not including 3 and 12. And on C, X less than or equal to 9, that is everything, right, at most 9. So everything up to and including 9. So here for D, our success again is back to owns a tablet. Failure is does not own. N is still 15. The probability that they own a tablet is 0.43, so that's our probability of success again. And we want more than 6, so 7, 8, 9, so that's everywhere that X is greater than 6. So again, the values that we are adding is 7, 8, 9, 10, 11, 12, 13, 14, and 15. And keep in mind when I say the values we're adding are the probabilities for each of these. So binom.dist for 7, 15, 0.43, 0, plus binom.dist for 8, which is why the tablet helps. So we got the probability that X is greater than 6. Again, we are adding the probabilities for 7 through 15. And let's see, I got 0.4847. So that rounds up the chunk on binomial distributions. So you will probably make sure you read the question carefully. If you are solving with a binomial distribution, it will probably say that for you. Okay. Question 4. Round the following probabilities to 4 decimal places. We are talking both in terms of z-scores and raw scores. So determine the area under the standard normal curve left of z equals 0.92. So we are going to start by labeling this. If it's a standard normal curve, my mean is 0, and I count up standard deviations. 1, 2, 3. This is the way that we kind of standardize. If I want to compare ACT scores to SAT scores, they're measured on different scales, but I can see how many standard deviations above or below a certain score is. Okay. And since we talked about z to the left is less than, z less than 0.92. So my 0.92 is roughly going to be right here. 0.92, I can label it. I want to the left, so I'm looking for this part of the area under the curve. It is important to remember that Excel always accumulates from the left. Okay, so the Excel command that we're going to use, because it is a standardized distribution, because we're using z-scores, is normal.standard.distribution, norm.s.dist. When you type that in, when you choose that, it's going to ask for z and then the cumulative. So first off, if we don't have a z-score, if I have an x and a mean and a standard deviation, I have nowhere to plug them in this command. So that should be a big hint that that's not the command I want. Okay? If you choose the correct command, it is going to ask for what you've got. So what am I looking for? Probability that z is less than 0.92. My command here is going to be norm.s.dist of 0.92, that's the z-score, and then 1. I do want an accumulation. This is different. Binomial distribution, we always stick a 0 in at the end. Normal distributions, it's always a 1. Probability here is 0.8212. The second part of this is different. And you notice I skip over A, I start with B, because for whatever reason, for me, that just kind of helps me put things into perspective. So when it says n parenthesis 14.3 comma 3.2, that is a normal distribution with a mean of 14.3 and a standard deviation of 3.2. So that means as I go up one standard deviation, I'm adding 3.2. Difficult to see. Let's see if I can do a little better here. So there's one standard deviation, there's two, there's three, and going the other direction, we are subtracting a standard deviation. So to the left, when I counted 1, 2, 3, this time I am actually counting, adding the true standard deviation. So I got 14.3 plus 3.2 is 17.5. Plus 3.2 is 20.7, and plus 3.2 is 23.9. Notice that I'm labeling the actual tick marks. When I go the other way, subtracting 3.2, I get 11.1, and then 7.9, and 4.7. I am not using norm.s.dist this time. I do not have a z-score. It's not a standardized distribution. Oh, wait, back up a second. So my probability notation, I want x to fall between 3.1 and 17.7. When we are talking about normal distributions, less than or less than equal doesn't matter, because each of these individual skinny rectangles has no area. But when we add them all up, that's when we get our area. Okay, so 3.1 is somewhere way down here. Our Excel command this time is just going to be normal distribution, norm.dist. When you type that in, it is going to ask for the x value, the mean, the standard deviation, and again, that cumulative. Now, because this accumulates from the left, what we're going to do is go all the way up to the 17.7. So we're going to go norm.dist. 17.7, my mean is 14.3, my standard deviation is 3.2, my cumulative is 1, and then I'm going to subtract off this part here. And I'm guessing this was a typo. It was probably supposed to be 13, but we're going to go with it. I got 3.1, 14.3, 3.2, and 1. It's easy to cut and paste here because everything's changed. Everything's exactly the same except for that x value. Our probability here, I got 0.8558.